Here we will continue using Python. First, we will create an impulse, meaning there is a 1. We will multiply this 1 by a factor, and we'll make it 0.1 to keep the signal smaller, followed by as many zeros as we would like to produce for the impulse response. Then we will use the SciPy signal L filter to generate the impulse response. So there we need to observe that the L filter function expects the A coefficients, and here it will be called the K coefficients, with opposite sign. So what we are doing here, we are importing signal from the SciPy. We are defining our sampling frequency. We are defining the length of our sequence as 2 times the sampling frequency, so be 2 seconds. Then we are calculating again our omega, and then we're having K1 and K2, because now it's given by these, what we previously called A1 and A2 from this transfer function here. Just calling K1 AK2. Then we're building our impulse. So we start with zeros with the length of the sequence length, and we add a value at position 0 here. It's 0.1. As mentioned before, we want to keep the signal smaller. We can then play back the resulting impulse response to our audio output. We are using the IPython display audio function. Here's our filter. Here we're filtering using the L filter, and then we have here our array. And remember that we just told that the filter expects the A coefficients with opposite sign. We have here minus K1 minus K2. So it should sound like this. Observe that it indeed sounds like a small bell or a xylophone or some kind of a percussive metal oscillating instrument in this category of bells and xylophones.